Assalamualaikum warahmatullahi wabarakatuh to the panels, Dr. Muhammad Afzan and Dr. Siti Rabizah. My name is Yusrina binti Azman and I will present to you my final year project proposal on finite element modeling of a carbon fiber reinforced epoxy structure using PCOMP element. Before we go to project summary, let me introduce you a bit about experimental modal analysis (EMA) and carbon fiber reinforced polymers (CFRP). Decades ago, EMA has been used to obtain data about structural damping. In EMA, vibration analyses are taken instantly from physical structure, and without any premise about the structure, it shows that EMA models are more reliable than FE models. In designing structure that deal with dynamic loads, it is important to determine the natural frequencies and to recognize the free vibration characteristic of the structure. Next, carbon fiber reinforced polymers is a polymer composite that consists multiple layers of fibrous materials. Among many composites, CFRP have known for its excellent characteristic, and it has been used in many industries. For example, aviation industry, defense industry, and material for buildings. First of all, let's start with the project summary. This work presents the FE modeling for carbon fiber reinforced epoxy structure (CFRE) using ply element and orthotropic material properties. To determine the modal parameters, which are natural frequencies, mode shapes, and frequency response function (FRF), normal mode analysis, and modal and direct frequency analysis will be performed to calculate those parameters. The accuracy of the developed FE model will be evaluated by comparing the calculated natural frequencies, mode shapes, and FRF with the EMA results. Next, we move to the problem statement. Finite element method is an analytical method that used to determine the values of modal parameters, which are natural frequencies, mode shapes, and FRF, approximately to experimental modal analysis. The geometrical of the CFRE structure is ply by ply, and the concern of ply orientation make it very challenging to determine the modal parameters. This analytical method then will be compared to the experimental counterparts to validate its accuracy. Next, we move to the objective of the project. The first one is to develop the FE model of carbon fiber reinforced epoxy structure. Second, to identify the natural frequencies, mode shapes, and FRF by using normal mode analysis and modal and direct frequency analysis. Third, to evaluate the accuracy of those parameters, which are natural frequencies, mode shapes, and frequency response function (FRF). Now, let's move to the scope and limitations of the project. First, the composite plate is carbon fiber reinforced epoxy structure. Second, the FE model developed by using PATRAN NASTRAN. Third, normal mode solutions will be using Nastran SOL 103. Fourth, the first 10 modes only will be studied. Fifth, the range of the frequency is between 0 to 1000 Hz. Sixth, the FE model is free boundaries condition. And seventh, the orientation of fiber is 0 degree and 90 degree. Now, let's move to the methodology of the project. The first step is develop the FE model of carbon fiber reinforced epoxy structure by using MSC PATRAN. Second, only the first 10 modes of the carbon fiber reinforced epoxy structure will be studied via normal modes solution. At this step, we will see the natural frequencies and mood shapes of the composite plate. The third step is the frequency response function FRF will be derived from modal and direct frequency analysis. The fourth step, only one desired FRF of the composite plate will be identified, and the last step is the result from FE model will be validated with the experimental counterparts. So this is the preliminary result after I apply the normal mode solution on the composite plate. As I mentioned in the scope and limitation of the project, only the first 10 modes of the composite plate will be studied. So as you can see, there are mood shape number 1 until mood shape number 10, and besides it, it's natural frequency of the composite plate according to the mood shape. Last but not least, I would like to thank Dr. Muhammad Afzan and Dr. Siti Rabizah for view my video presentation. Thank you.